Okay, so in this video we're going to be looking at energy and amplitude of waves. Now waves are energy, and we're going to be looking at how amplitude kind of feeds into the amount of energy that a wave has. Alright, so the first two things you get to do are not necessarily fill in notes, but answer questions. So I'm going to talk about this, and I want you to think about a complete sentence that says what things about the wave are the same and what's different. Okay, we have two transverse waves. Alright, so let's see what we're looking at here. Now, this y-axis here is our displacement. So basically, how far from the reference point or the center point of the wave does it get? Okay? So the farther up it is, the farther away it is. Wave B is closer. So it doesn't get as big of a wave. So if you think about, yourself with a slinky, little tiny shakes, big shakes. Okay? Now, if we compare the pattern of the wave, they both start really high and they get low at the same point. And they get high at the same point. And they get low at the same point. Okay? Now, that means the wave has the same pattern, okay, or the same wavelength. Okay, well, they all have the same pattern, but it has the same wavelength, because if you think about it, from where it repeats. So this top point right here, alright, this is where it starts to repeat. So they each have the same wavelength. Okay, so they have a different height, they get different bigness, but they get bigger at the same point. And they have the same distance between the bigness. So you might want to consider using other words, such as wavelength, okay, and displacement when you're writing your complete sentences. If you need to pause the video, you can. Okay, now let's look at a couple of definitions. We all like our new words. So one of our new words is amplitude. Now, amplitude was present in that graph picture, okay, and in the wave picture below us. Amplitude, when you're showing it on a graph, tends to be a double-headed arrow. Okay, it's basically showing that this part of the wave moves from top point and then down to the bottom point. Okay, so it moves up and down right there. Now, amplitude is the distance of maximum height or depth. Okay, so maximum height, how high it gets from the reference point, from that center line. Okay, so maximum height or maximum depth, how far down it gets. Those values will be the same. Okay, your wave will have the same amplitude whether it's going up or down. The units for amplitude, well, we're talking about distance. Whenever we're talking about distance, we deal with meters. Oh, sorry, hold on. That would be the units. And our symbol is a capital A, not a lowercase a. Lowercase a is acceleration, uppercase A is amplitude. Alright, now if we go over and look at the crest and the trough, you can actually knock out the symbol and the units. Alright, we don't need those. The crest is the part of the wave with the greatest magnitude. Now when I say that, that is this point right here, and this point right here, and this point right here are all crests. Okay, highest above the reference point, greatest magnetism. Now trough, think about like a horse trough. trough. Okay? Of course, trough holds water, so it's going to be the bottom part. Alright, so it's the part of the wave with the least magnitude, or the lowest part. Okay? So we talked about amplitude being the distance of maximum height or depth. Maximum height is happening at the crest. Maximum depth is happening at the trough. Now, last thing, identifying wavelength tip. So we've been talking about how when it repeats, we pick it up. All right, so every time it repeats, it's the wavelength. Now, if you're looking at a wave, consider crest to crest. So one crest to the next is going to equal one wave. One wave is also trough to trough. What do I mean by that? If we look down here at wave B, crest to crest, one wave to crest. So that's one wavelength, lambda. That's one wavelength, lambda. Same idea with trough to trough. Okay? That's one wavelength, lambda. Okay? Not too bad, right? Now, waves are energy. Waves allow for the transfer of energy from one point to another. Waves are a form of energy. Okay? Or form of energy transfer. Now, wave motion, so this box right here, we're going to say wave motion transports the energy without transporting the medium. Excuse me for running out of room. Okay, now what does that mean? That means that, let's see, sound is a wave, correct? So, when I produce sound, I give the molecules in the air, or whatever medium I'm in, whatever substance I'm in, vibrations. Okay? And that those vibrations travel through, like a wave. But by doing that, I'm not actually, the sound itself is not causing the air to be bombarded at you. That's why if you think about it, if it did happen, if everyone yelled at you, you'd feel like this big gust of air coming at you. But you don't do that because the medium isn't transferring, only the vibrations are. The medium, or the molecules or substances, stay in the same place. So if we look at wave A here, this guy, if we consider this to be one molecule, he does not go with the wave. Okay, he does not do this. No. He just moves up and then down. Up and then down. Okay? He stays in the same area. He just moves up and down. Okay? So, what is that I just said? I said that the medium that carries the energy of the wave does not travel with it. Okay? So the wave doesn't pick up things and take it along with it. So in a perfect ocean, without, any extras, just plain waves, you would sit on the wave, like on your surfboard or whatever, and it would bob you up and down, but not move you closer or farther than to shore. But that has to do with the fact that, waves have undertows and reflections and things like that, and there's other things going on there. I was going to have you fill this in when we did lab, but I'd rather have you do it now. All right, so this whole lesson is about energy versus amplitude. We've learned about how waves are energy, and we've learned what amplitude is. Now, here's how they're related. Energy and amplitude are directly related, which means direct relationship that as amplitude, which you will sometimes be seeing written as this, I'm just going to shorten it down, as amplitude increases, energy of the wave increases. Okay? So if we look at wave A versus wave B, wave A has more energy because it has greater amplitude. Okay, we're going to be looking at that with the slinky, little tiny things, big things. All right. Now, my question to help you with. Draw a transverse wave with an amplitude of 5 meters. Label the crest and trough of the wave. Use a double-sided arrow to show the movement of one particle as the wave passes through it. All right? So it didn't actually give me a wavelength. So I can do whatever wavelength I want as long as it has 5-meter amplitude. So let's see. Wait, 1, 2, 3, 4, 5. All right, let me fix this. Let's see, 1, 2, 3, 4, 5. So if I make blocks, each worth 1. Oops, didn't mean to take that with me. Let's see if we can do it without doing that. And I'll do it in red. 1, 2, let's go with 1, 2, 3, 4, 5. So my wave goes up 5, comes back down, 1, 2, 3, 4, 5. And up to 5 and down, and up and down, etc. Okay, so I'm showing an amplitude of 5. Okay, and I showed that over here. That's my displacement. Label a crest. You are a crest. You are a trough, as are you. And I use the double-sided arrow, which I'll highlight in green to show the distance. So that's all that was needed to do for that. Now, does the particle move with the wave? Why or why not? No. The particle doesn't move with the wave because waves are energy and only energy moves with the wave. Okay, so that's my question. Next comes yours. I did put something over the graph, so, because we're each a little different graph. but you're going to be looking at your version for this. All right, make sure you remember to do it online. The form will be there on the website. It is not currently, but I will make sure it's up. You will see it here. What I'm going to do is I'm going to put lesson 1 down below, and so it'll be right here. Okay, and then it will be lesson 2 that you're dealing with, not lesson 1. All right, good luck.